So let's continue with this week's videos. So for this video, I'm going to talk about how to create a sub VI. So basically, when you create a program, your program can get bigger and bigger and bigger depending on like what you want to do inside your program. You might do several different things in one program. And once you're building in your block diagram, this block diagram can get larger and larger and larger. But there's a way that you can make the block diagram look cleaner and tidier, and you can troubleshoot your program better. And that's by creating a sub VIs. So VI is actually your big program, and sub VIs are actually a simpler and smaller programs that you put inside your big program or inside your main VI. So basically, when you create a sub VI, you are kind of creating a function. So when you click on LabView, there are some functions that the programmers in National Instrument, they created and put it in the LabView program. But when you create a sub VI, you're kind of creating a function that you can add in your program that specific function does the specific thing that you defined for it. So let's get started, and then you will understand what I mean better. So in today's example, we're going to create a program that can change the temperature in Fahrenheit degree to centigrade degree. So first thing first, you go to the front panel, right click, go to numeric, and choose a thermometer. You do it one more time, and you change this thermometer to like label it that this is your Fahrenheit, and this one is the one that basically shows the centigrade. So yes, notice the triangles here on the block diagram of each one of these thermometers. The triangles are in the left side. So that means that a signal can only get inside this thermometer. So this basically shows that these are only indicators. So these basically show the temperature at the end for you. So you may want to need a control too. And your control is for your thermometer, because for the thermometer at degree Fahrenheit, because you want to type, okay, at 32 degree Fahrenheit, what would my thermometer show at based on the degree centigrade. So you need a control here too. So you right click, go to numeric, and then numeric control. By now I'm sure all of you know how to bring a control, and you will call this temperature in Fahrenheit. So now notice this, which is basically this. So as I told you, you can double click on the block diagram. It will show you where it is in the front panel, that specific icon or control, or the other way around. You can double click on the front panel and it will show you where it is in the block diagram. So notice that the triangle for this one is actually on the right side. So this is a control. And yes, we defined a control. So I'm just gonna bring it here. So I'm gonna wire these two to each other. So basically whatever I type in the control, it will be shown in here in this indicator icon, so I can see it on the thermometer too. So let's do another thing. Let's change the colors of them so we don't confuse them. I said that I want to change the color of the thermometer in degree Fahrenheit into, say, blue. So you select that thermometer, you go right click. I have talked about this before. You go to you right click and go to properties, and here you go to display format scale. No, let me find it. Yeah, it was on the face page appearance, and then click on the fill and then choose any color that you want. I'm gonna go with blue, and now you can see that this is in blue and this is in red. I want to, so what I want to do is that I want the user to type the temperature in degree Fahrenheit, and I want this indicator here showed whatever user typed, and I want, once I run the program, I want the program to give me the temperature in degree C. So let me show you the equation from degree C to degree Fahrenheit, or vice versa. So if you want to do this, you basically, centigrade to Fahrenheit, this is the equation. So Fahrenheit to centigrade is the other way around. So we have to subtract the number first from 32 and then divide it to 9/5, something like that, or multiply it to 5/9. So let's do it. So the first thing is we go to the block diagram, numeric, and then subtract. And we subtract our temperature from 32. So it doesn't matter where, you can go from here and then connect it to here, or you can go anywhere on this wire. It doesn't matter, because this wire only transfers the number, the floating point number of temperature. And again, notice that this is orange. That means that it's a floating point number. It's like a real number that you type. It's not a string or a boolean. And then you right click on the Y and say create a constant, and my constant here is 32. And the next thing you actually need is to divide 5/9. So again, here you go to the block diagram, you right click, go to numeric, and choose divide function. And then on the left, dividing x by y, we want to divide 5/9. So right click, say create a constant, and that's a 5. You feel like, you think here that this 5 is connected to the bottom knot, but it's not. If you move it, you will see that this is connected to the top knot. So just don't get confused if you see anything like that. For the y knot, right click and say create a constant, and this is a 9. And then you want to divide these two numbers to each other and then multiply to the results of this subtract. So we need another function called multiply. So the results should be multiplied to the results of this. And here then you will have your temperature in centigrade. So you can either have the results as an indicator with like a thermometer, or if you want to have an indicator like this, it will show you the real number, you can have that too. So you can right click in here, you can right click and say create an indicator, and then you can call this indicator as temperature in degree Fahrenheit. So then the results of this and this are actually the same. And notice that this indicator here is no longer white, but it's rather gray. That means that this is an indicator. So now save the program. I've already saved that. So save the program, and I've saved it from like as Fahrenheit to centigrade. Save it, and then let's run it. So we know that 32 degree Fahrenheit should be 0 degree centigrade. Oh, okay, so this is centigrade, sorry. So let's run it, and yeah, you will see it's 0. So you can type any temperature in degree Fahrenheit, and we'll get the results in degree centigrade. So this was pretty simple and easy. I'm sure by now all of you can do it easily. But I want to talk to you about something else, about creating a sub-VI. Before that, let's add this whole thing in a while loop. So this whole program will run once until you click on stop. So go to structures and then a while loop and put everything inside a while loop. This while loop is not complete until you assign a stop button to it, which I just did. So now this is complete. Now if I run this, this will always run, and I can play with like different temperatures, and I can see the results of them, like changing them like continuously, and then see what the results will be. And whenever I'm done, I'll just click on stop, and then the program is executed. So now say that you don't want to have this part of like the calculation from Fahrenheit to centigrade like always, and you want to create a little sub VI that actually does all these calculations, like all these functions are built into one function. So I'll show it to you what I mean. So let's select this part of the program that does all these mathematical calculations, and then go to edit and create and select create sub VI. You can see this is your sub VI. So basically all these calculations, all those like multiplication, division, like subtraction, they are all added into one function and on one sub VI. So you don't have to do it always whenever you have something in your program. You just have to add that sub VI into your program. Assume that you are having like a controller or something in your lab that measures the temperature based on degree Fahrenheit. And over and over and over again in your program, in your LabView program, you need to change that to degree centigrade, because this is the SI unit where you actually report your data and write your papers and stuff. So you don't need, when you create this sub VI, you don't have to always do this like subtract, multiply, dividing and all these things. You just add your sub VI there and tell the program whenever you see degree Fahrenheit, do this mathematical function on it and give me the degree centigrade. This way your program gets smaller, cleaner, and easier to do. So notice, like, if I like delete these two wires, notice when I stay on this sub VI, it's asking for a temperature in Fahrenheit and then a numeric, which is my indicator here. So it's asked for an input and it will give us an output. You can see an input coming in from the left, output always going out from the right. So it asks for an input and output. So let's double click on it and it will open this sub VI for you in another VI. So if I go here, so this is sub VI. It gets your degree in Fahrenheit, do all this calculation and give you a numeric, which is your results. You can always change that and say temperature in centigrade if you feel like it's easier for you to follow. So this sub VI is running this part of the code for you, and now you can save this because it has to be saved. If you don't save this sub VI, it's gonna get lost and it's not gonna run. So it's kind of like MATLAB when you create functions and functions. All of them should be into one folder to be run together. So when you are running a big VI that you have created several sub VIs, you have to first name all those sub VIs and save them. And they have to be saved in the same folder as your general and bigger VI. So let me show you this. So I will save this in the same folder that I have my Fahrenheit to centigrade, and I will call this I don't know, something like a sub VI. So I know that this is a sub VI of this. So it has to be saved, don't forget about it. And then you can see that this arrow here is broken. That means that these connections are not done. So it will ask for the temperature in Fahrenheit, you will create that for it, and then a temperature in degree C, and you connect that for it. So this way, let me turn on the light bulb and then run it. So it will come, run, go to this sub VI, generate the results, and get out. So all these things, like if I change the temperature now to 30, you will see now it generates a different result. So it will basically, on the background, this sub VI is running. Let me open it for you. You can see this sub VI is running on the background. You can see the run button is on, but it's saying that this is a sub VI that is running. And you can see that this window is no longer like meshed. It's basically a plain gray window. That shows that this is running. So if I turn on the light bulb here also, you can see how this is running and creating the results. So basically this big VI is running with this sub VI in the background. So let's stop this. So now that I have stopped this, you can see this is also stopped. So creating a sub VI is really useful. As I said, try to create as many sub VI as you can once you are building your big VI for your project. It's going to be really useful. So now let's double click on this, and it will actually send you to their sub VI project. I want to move these things here, and I want to show you several things. Like here, this is the icons for your sub VI, and these are like some grids for your VI. So if I click on like you can see all these grids are, most of them are white, just 2 of them are orangish color. So if I click on one of them, like this one on the left, it will kind of show this for you, and this one on the right, it will show you this. So notice that they are orange in color. That means that they are floating point numbers, right? One over here which looks like that, it means that this is an input, and the one that is looking like this with like a bigger border, that means that this is an output. So basically what I want to tell you is this. We have easily created this sub VI by just where was I? By just selecting the part of the project and going to edit and then saying create sub VI. So this method basically assigned the 2 inputs and outputs into this mesh here. Assume that you want to assign something later. So I will tell you what I mean. Say that we want to create this part of the project, which is changing the temperature to centigrade, as long as a specific button is on. So for example, on your project, you want to always change the temperature from Fahrenheit to centigrade, but sometimes you don't want that to happen. So you want a button to say that whenever the button is on, change the temperature from Fahrenheit to centigrade. But sometimes you don't want that, so you turn the button off, so it won't happen. And we know that for it, we need to have a case structure or an if statement. So if the button is on, do this. If the button is off, do nothing. So that's why you have to put the whole thing inside a case structure and assign a button to it and say if the button is on, this is true, do the whole thing. If it's off, this is false, and then do nothing. So we'll go to the front panel of this and then right click, go to Boolean and choose a push button here. And now take that button off and then connect it to the case selector here. So now when the button is on, this is true, the whole thing happens. When the button is off, this is off, and then basically nothing happens. So now we have another control that we can assign to our sub VI and then have it in our bigger VI. So previously, we just selected the part of the code that we wanted and said create a sub VI, and it automatically created these 2 for us. What if we want to change it ourselves? Or what if we want to write a sub VI separately from the beginning ourselves, and not in the bigger program? So this is how you do it. This is how you assign it. You will select the control or the indicator that you want to be added to your sub VI, and then you come and click here and then click there. So you basically click here and then click there. So you see now this color is green. It doesn't matter where in your in the mesh you click. So I'll say Control Z and I'll do it one more time. Maybe I want to click here and then okay, I didn't do it right. Maybe I want to click here and then click here. It doesn't matter. It really doesn't matter where. One of these points, one of these grid points. You can click on any one of them. So now I have assigned, you can see this is a control because there's no like large, like bold border on it. So now I have assigned this boolean, this button, as another control. So if I go to my project here, you can see there is another node here that is on. Previously it wasn't there, it was only the input and output. Now we have another node, and that's for the boolean. And you can add a boolean here by right clicking, saying choose this push button, and you can say turn on the button if you want to convert F to C, something like that. It's always good to have enough information for the user. And then all you have to do is to connect this to that. So instead of like adding a case structure here, adding all those functions of subtraction, multiplications, division, and all these things, you can create a sub VI that basically does everything for you, and then connect that. When that sub VI is created, just connect the nodes to it. So again, I want to show you this again. So again here, this sub VI gets the degree in Fahrenheit, change it, convert it to centigrade if the button is on. If the button is off, it will come here and do nothing, so nothing happens. And then when you create this sub VI, you basically assigned whatever control or indicator you want it to be as an input or as an output for the user, and then the user has to come here, not the user, actually the programmer, which is you, has to come here and then connect all the wires to the appropriate points. So connect the control wire to the control, the indicator to the indicator, which is the output, and the boolean to the boolean. So green to green, yeah, orange to orange, and orange to orange here. So this is what a sub VI really do. So now, so say that this is off. So if I run it, it does nothing. See, I will turn on the light bulb here. I'll go to here, to the sub VI, turn the light bulb here, and you can see that it comes to this page, which is the false page, and it does nothing. It doesn't go to the true page. You can see none of them are running. It goes to the false page. Like if I go to the true page here, it will take me back to the false page, saying that it's happening in the false page because the button is off. So it does nothing. So yeah, and I can stop it. On the other hand, if I turn this on and then run it, it will go into the sub VI again. And in the sub VI, if I go to the block diagram, it will take us to the true page if I turn on the light bulb. See? Now it's producing you the results. Creating sub VI is really helpful. It will make your program cleaner, easier to follow, and easier to understand. So I really recommend creating sub VIs whenever you are having a really big program, or even for smaller programs, because this way you can come and look at your code later, like after a month or so. You can come and look at your code and say that, okay, so this is where my temperature in Fahrenheit comes, and it depends on whether the boolean is on or off, and then I'll get my results, rather than like having everything into one code. So I recommend doing that. There's another thing that I want to show you, and is to change the way that this function, this sub VI looks like. So if you double click and go there, so you know what this mesh grid does. You know that you can assign each one of these control indicators or whatever that you have into these mesh grids. Now there is another thing here, and if you double click on it, it will take you to this page. And in this page, you can basically change the way that this icon looks like. So one thing that you can do is, for example, is to go to layers and then or like, let's say graphs, like to go to the glyphs, and then I want to add I think there was a thermometer. Yeah, you can add a thermometer here, and then go to layers and say that you want to delete this layer and just keep the thermometer here. And you can add a text and say that this is Fahrenheit to degrees C, something like that. And you can add a border for it, and you can change the color of the border. Like, it really depends on what you want to do. Like I haven't played with it so much, so yeah, just depending on what you want to do, you can change different colors, give different colors. Just this is just, you know, to make it look pretty. So depending on what you like it to look like. So once you click on OK, now this icon is changed, and you can come here and this is also changed. So then when you come back to see your program several months later, you don't get confused. You have some like information. Oh, it looks like it's changing the temperature for me. So I know what this LabView really does. It's just to make it look pretty. And then you have to save everything. Just don't forget that a sub VI has to be saved in the same folder as your VI, otherwise it won't run. And it's just better to do that. And use sub VI whenever you feel like you can make your program cleaner. And that's it. That's for the sub VI. I guess in the next video we will start working with arrays. And actually, once I'm teaching you how to work with arrays and matrices and all these things. As you move forward, you can create more sub VIs and practice whatever I have taught you so far. Like we are practicing the while loop here, or the for loop, or the case structures. We are practicing, and I taught you how these functions work before, but with new programs we are practicing it. So don't worry about this. We'll practice more of the sub VIs, but just learn it. It's really useful. See you in the next video.